Rahim. This is Jahangir Samro, Assistant Professor, Electrical Engineering Department, Sakhara University. Uh, Now we are starting lesson 6 using decision making structures. In this lesson, you will learn to create different decision making structures and be able to identify applications where using these structures can be beneficial. Topics covered will be case structures, event driven programming, and you will cover two exercises, exercise 6.1 and exercise 6.2 in this lesson 6. Alright, so let us discuss basically what is case structure, recognize and use the basic features and functionality of case structure. We will also look about case structure review, creating and configuring case structures, select a terminal data types, input and output tunnels in this lesson. Okay, case structures review. Now first and foremost important question is, what is the purpose of case structure? So basically a case structure executes one of its subdiagrams based on an input value. Each case structure will have two or more subdiagrams or cases. Case structures are similar to case statements or if then else statements in text-based programming languages. Alright, so it's very clear from the discussion that case structure executes one of its cases based on the input value, based on the selector terminal condition. Now the next question is, how many cases does a case structure execute at a time? The answer is that case structure execute one case at a time. The third question is, what is the purpose of case selector label? You see, this is case selector label. So the purpose of case selector label is to show the name of current case and enable you to navigate through different cases. You can see different cases which are present, which are available. So you can navigate through different cases using this case selector label. Now question number fourth and last question is, what is the purpose of this selector terminal? Now basically this selector terminal let you wire an input value to determine which case executes. Like if in this case number is greater than 0, if this condition is true, then this true case will execute, otherwise false case will execute. Alright. So let me demonstrate basically how to create and configure case structure in LabVIEW. For this I open LabVIEW and I'm opening a new VI. You see, I go to block diagram, I go to structures and I put a case structure over here. Now this is a selector terminal, this is selector terminal, and basically this is case selector label. You can connect different data types with this selector terminal. For example, for now I am selecting boolean. Push button with this selector terminal. So if suppose it is true, if this is true, then I want that, if this is true, I want that two numbers should be added. Say suppose these are the two numbers. Call it X, say it Y. Create indicator here, label it Z. So, alright, and if this is false, let me copy it here, and if it is false, if it is true, and if it is false, I want that this should show me a constant number which is 0 in this case. So if it's false, I will get a constant 0. Let us run this, and let's make it 5, and let's make it 5, and let's make it true. In this case, addition should take place and this true case should execute. Now you see addition is taking place. If I add 6 plus 5, it will be 11. You see? And if it is false, then false case should execute, which should give me a constant 0 number. I hope it is clear. Let's move ahead. Okay. You can wire a variety of data types to the selector terminal, to this selector terminal. The case structure configuration changes based on the type of data that you connect. So you can connect Boolean as shown here. A newly created case structure defaults to a Boolean input. The case structure includes a true case and a false case. See, true and false case. Alright, let me demonstrate using this case structure VI. You see, you can either connect Boolean data type to selector terminal, or you can also connect integer, you can also connect string, also connect enum or array cluster. Alright, okay. So if I connect this Boolean, either it will have a true value or false value. If it is true, you see a random number will be generated that will be multiplied by 1000, and that random number will be shown over here on this output. Alright, and if it is false, now you see, please note one thing, that right now this is called tunnel. As we have already studied, this is called tunnel. Tunnel information is passed to the output using this tunnel. So this symbol of the tunnel shows that currently this output tunnel is not defined for any value. So this tunnel has not been wired. Therefore, this VI is broken. To avoid this, you must define the value for the false case for this tunnel as well. So, say suppose I create a constant here and label it 0. Now this is basically the tunnel has been wired for all cases, for true case and also for false case. In false case it will give constant 0 number, and now this symbol changes. Alright, now let us run this case structure. If it is false, you see false, then it will constantly show 0. If it is true, then a random number will be multiplied by 1000 and will be shown on to the output. You see, random number is generated. Okay, alright. Now let us try and connect let us take an other case structure and connect this number selection integer. Now you see 0, 1 integer numbers are shown. Say suppose if it is 0 default case, then say suppose if this is the case, let us create an indicator. Then I want a random number to be multiplied by 1000 and shown at the output. If it is case 1, it should show me constant number. Say suppose in this case it should show me constant 1000. Alright, now let us remove this case structure and run it. Now you see, if it is 0, then this case is by default executed. Here it is 0 and random number will be multiplied by 1000 and output will be displayed. If it is 1, then this case will be executed. It means it will show constant 1000 number. I hope it is clear. Alright. You can also add other case by making right clicking and clicking add case after. So this is case number 2. Let us say if it is case number 2, then it should show us a constant number of 500. So now there are 3 cases. Now you see 1 and 2. Say suppose if it is case number 2 is executed, you see constant 500 is displayed on the output. If it is selector label terminal is 1, then you see a constant 1000 is generated, and if it is 0 case, then random number will be multiplied by 1000 and output will be shown. Alright. Similarly, you can connect enum with the case selector. So right now there are 3 options in enum: option A, option B, option C. If it's option A, you see random number will be multiplied by 1000 and output will be shown. If it's option C, it will show constant 500, and if it's option B, it will show 1000. Right now it is option A, so random number will be generated. See here, random number is generated. If I select from here option B, you see in option B constant 1000 will be shown, and if it is option C, you see 500 will be displayed. Alright. Also, case selector terminal can be connected with the error cluster. Now I am connecting error cluster. Error cluster will show 2 cases, either a true case or a false case. Like, let me take a case structure. So when you connect with this, it will show 2 cases, either no error or error. If error is present, it will execute error case, otherwise no error case will be executed. Alright. Okay. Now let us discuss input and output tunnels. As with other types of structures, you can create multiple input and output tunnels. Input tunnels are available to all cases if needed. Output tunnels require that you define a value for each case. So be cautious using the use default if unwired option, because it adds a level of complexity to the code. Also, it can complicate debugging your code. Third reason is the default value may not be the value that you expect. So you see, this symbol shows that a tunnel has been wired for all cases, whereas this symbol shows that a tunnel has not been wired. And if a tunnel is not wired, if it is unwired, the VI will be broken. And this symbol shows that a tunnel that is marked as use default if unwired. Right click on the tunnel and select use default if unwired, and the symbol will be like this. Let me quickly demonstrate this thing in LabVIEW. I quickly take a cache selector, taking a push button. I see if it is true, addition should take place. Now this symbol shows that a tunnel that has not been wired, a tunnel that has not been wired, and therefore the broken VI. This shows broken VI. So you can also use default if unwired. For this, right click and click use default if unwired, and now this VI can be executed. But I again repeat, be cautious when you use default if unwired option. Alright, I press Ctrl Z, and the other option can be that you wire this tunnel with any value. Like I create a constant here and say 2. Now this symbol shows that a tunnel has been wired for all cases. I hope it is clear now. So I have already demonstrated that selector terminal can be connected with different data types, and I have already discussed the concept of input and output tunnels. Now let us move to exercise 6.1 temperature warnings with error handlings. So now we'll perform exercise 6.1 temperature warnings with error handling. So let us do this exercise. Okay. The goal of this exercise is to modify a VI to use a case structure to make a software decision. Scenario is you created a VI where user inputs a temperature, a maximum temperature, and a minimum temperature. A warning string generates depending on the relationship of the given inputs. However, a situation could occur that causes the VI to work incorrectly. For example, the user could enter a maximum temperature that is less than the minimum temperature. Modify the VI to generate a different string to alert the user to the error. Upper limit is less than lower limit. Set the warning indicator to true to indicate the error. So basically, in previous exercise, uh, we could make a change in previous exercise that if user has entered uh, maximum temperature that is lower than the minimum temperature, in that case user should get the warning that upper limit is less than lower limit. So this is a flow chart of the design. Now keeping this consideration of flow chart in mind, we will design our application. So I would only refer to this block diagram and will design the code ourselves without referring to assistance of this manual. So let us do it ourselves. You are requested to try it also from your side, and if you need any help you can refer to this video. Alright, so First, it should check that if minimum temperature is greater than or is equal to maximum temperature. If this is the case, yes, then error should be created and it should be displayed that output upper limit is less than the lower limit and true indicator should be shown. Otherwise, if it is no, then this portion of the code should execute. Now let us create a new VI and take this weather data in cluster here. Alright, we are taking unbundle by name to disassemble this cluster and take out three values: current temperature, maximum temperature and minimum temperature. Alright, go to structure and select a case structure and then go to cluster and select error input cluster. So now there will be two cases. If there is no error, this case will execute. If there is error, this case will be executed. Alright. In no error case, it should check if the minimum temperature is greater than or equal to maximum temperature. So pick a symbol of greater than is equal to. If minimum temperature is greater than or equal to maximum temperature, if this condition is true. See, if minimum temperature is greater than or equal to maximum temperature, if this is true, then an error should be created. So select another case structure. So if this is true, this case will execute. And if it is false, if this is false, then this if this is false, then this portion of the code will execute. Let us make false case first and then we will complete true case. If this is false, it should check current temperature is greater than or is equal to maximum temperature. Therefore, select here from greater than or equal to and check if current temperature is greater than or equal to this maximum temperature. Alright. Or you can also connect this here. Sorry, please reconnect it. Minimum temperature and this is maximum temperature. Here I should connect it with the maximum temperature and this is maximum temperature. Alright, if this is true, then we should, if this is true, then we need to take a string constant to display that it is heat stroke warning. And if it is false, it should display no warning. Alright. Also, we should check if the current temperature is less than, if it is current temperature is greater than maximum temperature is no, then it should also check if current temperature is less than or is equal to minimum temperature. So select less than or equal to, this one, less than or equal, and check if current, this is current temperature, sorry, this is current temperature, and this is minimum temperature. You see, this is minimum temperature. Alright. Again, take a select terminal, and if current temperature less than minimum temperature, it should display freeze warning. If this is true, it should show freeze warning. Otherwise, display whatever warning is coming from the previous here. Otherwise, if this is false, if current temperature is not less than or equal to minimum temperature, then show whatever the warning is coming from here, either heat stroke warning or no warning. Alright, and then go to cluster function and select bundle by name. Here it should show temperature warning and temperature warning text. So to show temperature warning, select not equal to. If here from it comes no warning, and so it will check whether the warning is coming or warning is not coming. Alright, and text will be taken from this point. Alright, copy it, change to indicator, name it weather data out. To see the output on the output cluster, connect it here. So now this portion of the code is complete. If now minimum temperature is greater than or is equal to maximum temperature, if this is true, yes, I mean if it's true, in this case it should show warning. So create constant here and make it true, and it should show that output upper limit is less than lower limit. So create a constant over here, and it should mention that upper limit is less than lower limit. So this true case is also complete now. Alright, and this is a false case. Also take one error output cluster and connect it with error input cluster. Alright, this is true case, this is false case, and if error is coming, if error case is true, then in this case warning should be activated true, and it should show error here. Also pass this error into the error output. So now your code is complete, and let us test this code. Let us make current temperature 20 and maximum temperature 50 and minimum temperature is 10. In this case, it should show no warning. And if the current temperature exceeds the maximum temperature 55, then it should show heat stroke warning. And if it is 5 below the minimum temperature, it should show current temperature is below the minimum temperature, it should show freeze warning. And if suppose your minimum temperature is greater than the maximum temperature, in this case it should show the warning, and it should show that upper limit is less than the lower limit. Alright, so the code is complete now, as you noticed. Thank you very much for completing this exercise. We'll continue part 2 of lesson 6 in our next video. Please try this code from your side as well. Thank you.